Alright, hi everyone, welcome to my YouTube channel CTF Electrons, and in this video we'll talk about iterative solutions, okay, of simultaneous linear equation. Now, for this method, it provides an alternative to elimination method, okay, obtaining the values that simultaneously satisfy a set of equations. We might suspect that such approximation method will be useful in this context. Now, this the idea here, iterative, keyword iterative, like iteration. So linear system, Gauss-Seidel, okay. So this is the most common iterative method for solving linear algebraic equation. So suppose for conciseness we limit ourselves to 3x3 sets of equation. If the diagonal elements are all non-zero, the first equation can be solved for x1, and the second for x2, and the third for x3. To start the solution process, initial guesses must be made for all the x's. The simple approach is to assume that they are all zeros. These zeros can be substituted into the first equation, which can be used to calculate the new values. I'll show you exactly what all these, paragraph, what they mean with this example. Okay, so use Gauss-Seidel's method to obtain the solution. Same problem we solved some videos ago. So now note that the solution is this: x1 is 3, x2 is minus 2.5, x3 is 7. Now they've given us the solution, so we are going to arrive at the solution using this iteration: first iteration, second iteration, third iteration. So solution. Now for this, from the first one, make x1 subject formula. Okay, you move this other one this way, move this one this way. Look at 7.85, look at it here. Move this guy this way, you have what? Plus 0.1 x2. Move this guy this way. Okay, divide by 3 so that x1 will be subject formula. That's why we had done this. Same to x2. Okay, x2 will stand alone. Divide 2 by 7. 7 will come under. This one, move it this way, becomes positive. Sorry, it becomes negative. This guy, move it this way, becomes positive. And the same to equation 3. Equation 3, 10. To make x3 subject formula, divide 3 by 10. So we have the 10 here. Move this guy this way, becomes negative. Okay. Excuse me. Positive 0.2. Okay, 1.4. Okay, that's what we have here. Okay, so move 0.3 this way, becomes positive. It becomes negative, please. Here comes to becomes, here should be negative. Okay, did I make that x3? x3. Okay, all right. So the next thing to do now is, after doing that, I believe you understand this first part. So after doing that now, the first thing to do to solve equation 1, we make guesses. Are we seeing it now? Initial guesses must be made for all x's. So this is the exact point where we now say, let the x's be what? 0. So while looking for the first one, we have this. Where is it? While looking for the first one, x2 and x3, let them be what? 0. So where you have x2, in this equation where you have x2, you put 0. Where you have x3, you put 0. That will now give you the value for x1. Okay, then for x2, we now have x1, x3 is still 0. So x2, look at the formula. x1, you put this value there. x3, you put 0. So with this now, we have value for x1, we have value for x2. x3 now, where there is x and x3 now, where there is x1, where there is x and where's my x3? Okay, x3. Where there is x1, you put that x1 value. Bro, what's happening? Okay, this is where we are. Sorry. This is where we are. So where there is x1, we've calculated the x1 value, we put it there. Where there is x2, we put the x2 value. This thing is minus, please. So that's minus. Okay, I think we've done that correction in the first place. Yeah, this minus. So let me make that correction here too. Here's also minus. Where anywhere I have that x3, that should be minus. Anywhere I have that x3, that should be minus. Good. Oh boy. So we are still in the first iteration, right? On that x3. So we've gotten x3 now. So that's the first iteration. So for the second, now if you look at the values, they are close. They are close to these values here, but they are not exact. x1 is close to 3. Okay, look at x1. It's close to 3, but it's not. It's not. x2 is minus 5 points. Minus 2.5. Yeah, this one is close to. Okay, x3 is 7. What do we have in x3? 7 points. It's close. So let's take the second iteration. So exactly the same thing. We are going to do exactly the same thing. However, we are no longer using 0 as initial guesses. Okay, because we now have values for x1, x2, x3. So in our second iteration, where we have x2, this is the x1 formula. We are going to use this formula all through, please. We are using all this formula all through. So for x1, where we have x2 and where we have x3, in the second iteration, where we have x2, we'll put this value for x2, plug it there. Here we have x3, we put in this value of x3 there. So we now have a new x1. So where we have, so for x2, where we have x1, we put this new value of x1. Where we have x3, we put the value of x3. So we now have a new value for x2. Then for x3, where we have x1, we put this current value, latest value. Where we have x2, we put the latest value. So we now have x3. So for third approximation, I believe we can see that we are getting closer to the real numbers. This one now is close to the real number. This one now is close to 3. So it's close to 2.5 minus 2.5. So we are getting closer to the numbers as the iteration goes up. So for our third iteration, same thing. For our third iteration, where we have x2, we'll now use this latest x2 value, put it there. Where we have x3, we use the latest x3 value, put it there. So we'll now have a new x1, which is almost exactly 3.0. So very, very close now. Then for x2, where we have x1, we put the latest x1 value. Where we have x3, we put the latest x3 value. Okay, so we have a new x2, very close to minus 2.5. So for x3, where we have x1, put the latest x1 value. Where we have x2, put the latest x2 value. So we have a new x3, which is approximately 7. Okay, so that's it for the iterative solution for simultaneous equation. Okay, so if you have any question, comment, like, share, subscribe, and then click on notification bell, of course. And this will be all for now. Thanks for watching.